Welcome to 6-2 using proportions. Our objectives today are to solve proportions or learn how to solve them. And after we've learned how to solve them, we're going to put them into real-world problems. Those are our two objectives. What is a proportion? It's a statement of equality of two ratios. And we learned about ratios in the previous lesson. The key concept here is that we take two ratios and we set them equal to each other. In our example, 2 over 3 is equal to 6 over 9. That is a true statement. We're going to learn now is how to check our two ratios to make sure that they are true. How are we going to check our two ratios? We're going to use this idea called cross products. Every proportion has two cross products. You can see here in this diagram that we have 12 over 84 is equal to 24 over 168. We say it's equal, but to test it, we're going to use cross products, where we are going to multiply across from each other. The first thing we're going to do is the ones in red. 12 is across from 168, so think of it as going from top to bottom. And then we're going to multiply 84 by 24. Think of it as going from bottom to top. We're going to remember to put our equal sign between the two. So 12 times 168 is equal to 84 times 24. With our calculator, we find out they're both equal to 2016. So these two ratios are a proportion because they are equal to each other. All right, on this page, determine whether each pair of ratio forms a proportion. So we're going to use our cross product, or what we just learned in the previous slide. All right, so I wrote 1/3 is equal to 3 over 9, and I'm going to go ahead and use my cross products. So in blue, I have 1 times 9 is 9. And then, of course, I multiply 3 times 3, the red. 3 times 3 is 9. And let's keep in mind that there is an equal sign in between both of them. Comparing the left side to the right side, yes, this is a true statement. B, 1.2 over 4.0. And I have 2 over 5. So I set them up as a proportion. I'm going to use cross products again. And so I am going to multiply 1.2 times 5. There's my red. And 4.0 by 2. As you can see here, 1.2 times 5 is 6. I have that in red. And 4.0 times 2 is 8. Are they equal to each other? No. So this is a false statement. Our next slide says solve each proportion. Okay, so what we have here is a proportion, which is two ratios equal to each other. We know that they're equal, but we don't know what A is equal to. So that's what we're going to try to find. I start off by using cross products. So 100 times A is 100A. Then I'm going to go ahead and take 25 and multiply it by 52, and I get 1,300. They're equal to each other, but I still don't know what A is equal to. I need to isolate the A. In order to do that, I use what I've learned in previous lessons. I'm going to undo the 100. Whenever I do on one side, I do to the other. With my math, I find that A is equal to 13. All right, let's try that one more time. We're going to solve each proportion. This time the variable is down in the denominator, but everything else will be the same as we've learned before. We're going to use cross products. All right, I'm multiplying 12.5 and 7.5, and I get 93.75 using my calculator. Now I'm going to continue on, and 15 times m is 15m. And remember then that they're both equal to each other, so I write the equal sign. Now I'm going to do, doesn't matter where my m is at, I'm still going to isolate it. So I'm going to use the lessons I've learned about solving equations. So I'm going to use the inverse of multiplication, divide both sides by 15, and my m is equal to 6.25. Alright, what we have here could be a real-world problem. It's a recipe for food. refer to the recipe at the beginning of the lesson. Well, I put it here right on the page. How much soda should be used if 16 ounces of each type of juice are used? Alright, so the first thing I'm going to do is I'm going to build a proportion from the word problem. I have the original juice and I want to compare it to our new juice or our new recipe, but we're also talking about our soda. So what I'm really comparing is the original recipe, which is the original juice, over the original soda, and I want to know if I change the new juice, how much new soda I need. So let me go ahead and replace these words or phrases with numbers. Alright, in the original recipe it took 12 ounces of juice and 40 ounces of soda. And what I want to do new now is change that to 16 ounces of juice. But I don't know how much soda I need. So let's go ahead and look at these proportions that I built. And with all proportions to solve them, I'm going to cross multiply. So in red, 12 times n is 12n. Then I'm going to continue on with my cross products. And I get 16 times 40, which is 640. And not to forget that they're equal to each other. Now I'm going to go ahead and isolate the n, which, of course, if you don't remember, my n is what my new soda is. So how do I isolate my n? I divide both sides by 12, and n is equal to 160 over 3. Or if we were actually shopping, we're probably going to look for 53 1/3 ounces. That's something more of a real world answer, but both are acceptable.